Hello everyone. Today let us discuss about kinematic equations for uniformly accelerated motion. We can derive these equations in two methods. One is analytical method, second one is graphical method. We can use both the methods, and in question paper they specifically ask you to use analytical method, then you have to follow this method. If they ask for graphical method, you have to use the graphical method. But in this present video, I'm going to derive the equations using analytical method. In our next video, we will discuss about graphical method. So let us see what is uniformly accelerated motion. So uniformly accelerated motion means that velocity keeps on increasing in equal amounts, like in equal intervals of time. So that is uniformly accelerated motion. It can be for any object. It can be a car going on a road. It can be a train. It can be any person walking. It can be anything, whatever may be the moving object. For that, we have to derive expressions. For uniformly accelerated motion, we can derive some simple equations. Those are called as the kinematic equations. These equations, they relate displacement S, time taken T, initial velocity U, final velocity V, and acceleration A. So these are the various terms which we will be using in this present topic. This is the topic. In this topic, we will be using these terms: displacement, time taken, initial velocity, final velocity, and acceleration. So let us go for the main four kinematic equations. The first one is V is equal to U plus AT. The first one is V is equal to U plus AT. And the second one is S is equal to UT plus half AT square. And the third one is V square minus U square is equal to 2AS. And the last one, S nth, that is distance traveled in the nth second. So we are going to use different things, different things. Here, the last equation mainly, we are deriving the expression for the distance traveled in the nth second. That is called as S nth. S nth. That is equal to U plus A by 2 into 2n minus 1. U into A plus A by 2 into 2n minus 1. So now let us prove the above four equations in analytical method in this video. So let us prove all these four equations in analytical method only in this particular video, as I told you. Now let's go for one by one slowly. Let us derive one by one. Let us consider an object moving with constant acceleration along positive x-axis. As I told you, an object can be anything, any car, train, person, bird, animal, whatever it can be. So let us consider an object moving with constant acceleration along positive x-axis. Because whenever you take along positive axis, it will be easy for us to do the things in a simple way. Here, as I told you earlier, u is the velocity of the object at an instant t is equal to 0. So the first one is u. That's called as initial velocity. When time t is equal to 0, time is not at all moved, means not at all has not at all moving forward at that particular time. That means when time t is equal to 0, initial velocity is u. V is the velocity of the object at an instant t. So that means after a time t, the velocity, final velocity of the object is v. A is uniform acceleration and s is distance traveled in time t. A is the uniform acceleration, S is the distance traveled in time t, and t is the time of traveling. T is the time of traveling. So now, first let us take the first equation. The first equation of kinematics, that is V is equal to U plus AT. V is equal to U plus AT. By definition of acceleration, we know that acceleration is equal to change in velocity, change in velocity divided by time. By definition, acceleration is equal to change in velocity divided by time. We know final velocity is v, initial velocity is u. After traveling, the time is t. Initially, time was 0. So, acceleration a is equal to change in velocity, final velocity minus initial velocity divided by time, that is t minus 0. Therefore, a is equal to v minus u by t. Therefore, take cross multiplication. AT is equal to V minus U, or V minus U is equal to AT. Then send U to the right side. Minus will become plus. V is equal to U plus AT. So V is equal to U plus AT. This is our derivation. V is equal to U plus AT. So this is the first kinematic equation. The first kinematic equation, V is equal to U plus AT. Let's go for the next one. Let's go for the next one. That is S is equal to UT plus half AT square. So our next equation is S is equal to UT plus half AT square. Here S is the distance covered in time t. Here S is the distance covered in time t. Here S is the time covered in time t. We know that the average velocity of the object in time interval 0 to t is given by V average is equal to displacement divided by time. So we know that average velocity of the object in time interval 0 to t is given by V average is equal to displacement by time. Displacement is S minus 0 by t minus 0. Therefore, V average is equal to S by t. Therefore, take the cross multiplication. S is equal to V average into t. Let it be equation number 1. Let it be equation number 1. Then V average, we also know that average velocity is defined as initial velocity plus final velocity divided by 2. So V average is equal to V plus U divided by 2, or U plus V divided by 2. Let it be equation number 2. Then substitute 2 in 1. Substitute the second equation in the first equation. Therefore, S is equal to U plus V by 2 into T. From the first kinematic equation, we know V is equal to U plus AT. So this is the first equation which we have derived. This is the first equation which we have derived. V is equal to U plus AT. Therefore, let us substitute this fourth equation in the third equation. Let us substitute fourth equation in the third equation. That is U plus, in place of V, we are substituting U plus AT, U plus AT, and whole divided by 2, already divided by 2 is here, into T. In place of V, we have substituted the first kinematic equation, U plus AT. Now, U plus U is 2U plus AT divided by 2 into T. Let us take separately 2U by 2 and AT by 2, 2U by 2 and AT by 2, whole multiplied with T. Then 2 and 2 cancel, U plus AT by 2 into T. Now we'll multiply each and every term with t. U multiplied with t is ut plus 80 by 2 multiplied by t is half at square. So S is equal to ut plus half at square. So S is equal to ut plus half at square. So this is our second kinematic equation. S is equal to ut plus half at square. S is equal to ut plus half at square. So first kinematic equation we have done is V is equal to U plus at. V is equal to U plus at. And the second kinematic equation, S is equal to ut plus half at square. Let's go for the third kinematic equation. Let us go for the third kinematic equation, that is V square minus U square is equal to 2as. V square minus U square is equal to 2as. This is our third kinematic equation. So, for this third kinematic equation, let us take the first kinematic equation V minus U is equal to at. That is from V is equal to U plus at. Send U to left side. V minus U is equal to at. Let it be equation 1. And already we have discussed V average is equal to displacement by time. V average is equal to S by T. Therefore, S is equal to V average into T. But average velocity is equal to V plus U by 2. This already we have done in the previous derivations. So we know this second equation, S is equal to V average into T. Let it be equation number 2. But V average is equal to V plus U by 2. Let it be equation number 3. So from first equation, let us take this first equation and write here AT is equal to V minus U. And keep T alone in the left side. Send A to the right side. Then T is equal to V minus U whole divided by A. AT is equal to V minus U from equation number 1. Then V minus U is equal to AT. AT is equal to V minus U. Take T alone left side. Send A to the right side. Then T is equal to V minus U by A. Let it be equation number 4. And substituting equation 3 and 4 in 2. 3 means V average, this one. 4 means T, this one. And these two equations we will substitute in equation number 2. S is equal to V average. V average from here, that is third equation, V plus U by 2 into T. T from fourth equation, V minus U by A. So S is equal to V plus U by 2 and V minus U by A. V plus U by 2 is V average. V minus U by A is time T. Then multiply them, it will become V plus U into V minus U, V square minus U square. That is from equation A plus B into A minus B is equal to A square minus B square. So therefore, in the same way, V plus U into V minus U is equal to V square minus U square. Therefore, S is equal to V square minus U square by 2A. Send 2A to the left side. Then V 2AS is equal to V square minus U square, or V square minus U square is equal to 2AS. V square minus U square is equal to 2AS. This is our third kinematic equation. This is our third kinematic equation. And let's go for the last kinematic equation. The fourth kinematic equation, distance covered in the nth second. The distance covered in the nth second can be obtained by subtracting the distance traveled in the n minus 1 seconds from the distance traveled in the n seconds. So what we are doing here is For example, we want to know the distance traveled in the 7th second. If the journey is for 7 seconds, just for example, I'm saying, if the journey is for 7 seconds, we will find the distance traveled in the 7 seconds. We will also find the distance traveled in the 6 seconds. Then we will subtract from 7 seconds the 6 seconds distance. That means we will subtract distance traveled in the 6 seconds from distance traveled in the 7 seconds. Then you will get the distance traveled in the 7th second alone. That means we want the distance traveled in a particular second only. If you want to know the distance traveled in the 7th second, first to find the distance traveled in the 7 seconds, then find the distance traveled in the 6 seconds, subtract the distance of 6 seconds from distance of 7 seconds, then you will get the distance traveled in the 7th second. The same principle we are using here. So what we are using here is the distance traveled in the nth second can be obtained by subtracting the distance traveled in the n minus 1 seconds from the distance traveled in the n seconds. So here you can see the journey started from t is equal to 0. Here up to this point t is equal, where my pointer is showing, up to this it is up to n minus 1 seconds. This is up to n seconds. So this is the last second. That means the distance traveled in the last second, called as Snth. Distance traveled from 0 to n is Sn. Distance traveled from 0 to n minus 1 is Sn minus 1. So you can see here, distance traveled from 0 to n. It is the distance traveled in n seconds. And distance traveled from 0 to n minus 1. This is the distance traveled in n minus 1 seconds. Then if you subtract distance traveled in n minus 1 seconds from distance traveled in n seconds, you will get the distance traveled in the last second, which I'm showing with the blue color. So now the blue color one is the distance traveled in the last second. This can be obtained by subtracting the distance traveled in the n minus 1 seconds from distance traveled in the n seconds. So let us take the equations. That is distance traveled in the first t seconds, second kinematic equation. St is equal to ut plus half at square. If it is n seconds, wherever there is t, we will substitute n. If it is n minus 1, wherever there is t, we will substitute n minus 1. Therefore, let us start. Distance traveled in the first n minus 1 seconds, Sn minus 1, u into, in place of t, we will substitute n minus 1, a, and then half a, and in place of t we will substitute n minus 1 whole square. So Sn minus 1 is equal to u into n minus 1 plus half a into n minus 1 whole square, equation number 1. Then distance traveled in the first 10 seconds. Substitute n in the place of t. Sn is equal to un plus half an square, equation number 2. Therefore, distance traveled in the nth second, Snth, that is equal to Sn minus 1. So let us take those equations and let us take those two equations and derive the distance, that is which I am showing in blue color. So here I'm showing with a blue color. This is the distance traveled in the nth second. For that, we have to do distance, we have to do the subtraction. That is distance traveled in the n minus 1 seconds. We have to subtract from distance traveled in the n seconds. N seconds is un plus half an square minus, keep a big rectangular bracket, and un minus 1 plus half a n minus 1 whole square. That is subtracting equation 1 from equation 2. Equation 1 from equation 2. That is, we are doing equation number 3 now. Then un plus half a n square minus un minus u plus half a. Then we have expanded it using a minus b whole square, n square minus 2n plus 1, and then what we have to do is now un plus half a n square minus un minus u half a. We are multiplying the three terms within the bracket, half a n square minus half a into 2n, this one, plus half a into 1. Then let us take them out from the bracket, multiplying with the minus sign, un plus half a n square minus un, minus into minus plus u, minus into plus minus half an a n square, minus into minus plus 2an by 2, and then minus into plus minus half a. Here plus un minus un cancel, plus a half an square minus half an square cancel, and what remains, let us write u. This u is there, and this 2an by 2, 2an by 2, minus half a minus half a. Purposely I have not cancelled this 2 and 2 because we can take out half a as common out. Then u plus half a take as common out. When half a goes out, the remaining will be 2n for this first term, and for the second term it is 1. Therefore u plus half a into 2n minus 1. Therefore u plus half a into 2n minus 1. So the fourth kinematic equation, that is the distance traveled in the nth second, Snth is equal to u plus a by 2 into 2n minus 1. This is our fourth kinematic equation. So with this, we conclude our topic of kinematic equations, and we have derived them using the analytical method. We have derived them using the analytical method. We will derive them in the next video. There, I just want to tell you this equation, all these equations we have derived for motion in a straight line on a horizontal platform, that is along positive x-axis. What if it is along a straight line, that is up and down direction? That means if something is falling from a building or a mountain, or something is thrown from the bottom of the earth to somewhere to a height, then we have different equations. In place of acceleration, we have to substitute acceleration due to gravity. We have to substitute acceleration due to gravity. For the bodies for falling vertically downwards, we have to take a is equal to plus g, s is equal to h. This is for the motion which is like from top of a mountain, from the top of a building, like that, when they are falling vertically. Then substituting a is equal to plus g, three kinematic equations we get. V is equal to u plus gt, h is equal to ut plus half gt square, v square minus u square is equal to 2gh. 2gh. Similarly, another case 2, for the bodies rising vertically upward from the ground. Vertically upward from the ground means we are throwing from bottom to bottom of the earth, or from the surface of the earth upwards. In that case, we have to take a is equal to minus g, x is equal to h, that is height, then v is equal to u minus gt, h is equal to ut minus half gt square, v square minus u square is equal to minus 2gh. The three kinematic equations we get, v is equal to u minus gt, h is equal to ut minus half gt square, v square minus u square is equal to minus 2gh. So with this, we can conclude our discussion on kinematic equations, that is by analytical method. Let us meet in the next video for the graphical method. Until then, thank you for and bye. Thank you for watching this video. Until then, bye. God bless you all.